So today I will show you how to solve this problem. So the statement is the statement is like you can basically understand it as giving you a number s and a number n. So so you have to write n numbers on the board, which which adds up to this sum 97, and you have to choose it so that when it is converted to the base 11, the sum of it in base 11 when it is converted back to base 10 is largest possible. So the link to the statement is in the description below. So I will just jump right into the problem. So how to do this problem? Um, so you can see that. Let me show you. You can see that. Oh, sorry. When a number is expressed in base 10, I'll give you an example like this. So its numerical value should be 8 times 10 plus 7, which equals 87. But 87, if it is interpreted into base 11, it should be 8 times 11 plus 7 equals 88, 95. So you see, here is the difference. So you can see that if we try to write on the board the numbers that are large enough, it's like you're trying to maximize this exponential by writing a long number on the board. Like if you have to express this 97 on the board, you have multiple choices to write it as 1 plus 96, 2 plus 95, etc. But there is only a few possible answers. So you may notice that this 1, 2, 1, 2, 9, this in base 11 is times with 11 times 11 to the power of 0, so that becomes 1. So this in base 11 is the same of them in base 10. The difference lies in these leading numbers. So this there is one possible answer is you can write as 10 plus 9, 10 plus 80, 87, or whatever you like, but just to make sure that this these leading numbers, you're trying to use the exponential of 11 times the position to make the sum biggest possible. So um, let's try another example. If I give you 111 and you have to express this in 4 numbers. You can see that in the example test, it writes as 3 plus 4 plus 100 plus 4. You still can see that it doesn't break down this 100 into smaller components, but it still use this 100. It doesn't analyze this 100, but that means like you analyze the smaller numbers, but let the bigger numbers in the sum so that they can yield the largest result. And so we can have some observations that we can break down of this. So if you want to, let's see, this has 3 digits, so you may want to store it as a sum of the numbers which also have 3 digits. So the smallest here is 100 plus, now you have 11 left. 11, this one you can express it as, you don't want to use this 100 because it's too big. If you try to analyze it into 90 plus 10 or 80 plus 20, you lose a lot because 80 is 8 times 11 while 100 is 1 times 11 squared. The problem is this squared. If you lose it, you lose a lot. So we don't want to touch it. We just want to choose the smallest number. No, the biggest number, but it is not a power of 10. This is not a power of 10, so you can use it to expand into 4 numbers. It's like 3, 4, 3, or anything you can choose because this is too small. This shouldn't change our result. Actually, this can be expressed into 10 plus 1 because this is a power of 10, so it has 2 digits. This one is significant to the result, but as you can see, this has only 3 numbers. It doesn't fit the statement. So we can have our general observation is that we can analyze it into the powers of 10 like this, but we shouldn't we do not touch these powers of 10 because as I said above, it will lose a lot. We will lose a lot of results. So we won't touch this, but we will choose the largest number, but it is not a power of 10, so that we can maintain these number of digits. Um, so but there's another problem. If 100, but you have to divide it into 2 numbers, what will you do? Because 100, if you in the normal in the regular situation, you will choose the biggest number, but it's not a power of 10 to maintain these number of digits, but this is a power of 10. So when you express it, you will this will yield two number with two digits. So as I said above, when you're analyzing a power of 10, you will lose one digit right here. That's lose 11. Lose That's like divides by 11. So to minimize that, you will choose in this case where you can't find when you can't find a number which is not a power of 10. So you will pick a number is a power of 10, but it is the smallest to minimize our loss. So that's it. That is the solution. This is kind of easy to implement, so I'll just walk through the code swiftly. So this you can there's only this number. It is a power of 10, so there's no more choice. This is the smallest power of 10 we can find, so we must express this as 10 plus 90. We express this we express this to uh, the smaller power of 10, and what we have remaining. Okay, so here is the code. Oh, sorry. So I create a vector. I push the statement into this vector, and then I make a while loop while the size this vector will store the numbers which adds up to the numbers which is in the statement. So I will check if we have reached the requirements or not. If we reach, then we get out of this while loop and we print out the answer, or otherwise we continue to execute these stuff inside. So I'll just iterate through the vector to choose to find the biggest number which is not a power of 10 and the smallest number which is a power of 10. So if we can find the maximum number which is not a power of 10, so we can analyze this first. Else if we can't find, we will take the smallest number which is a power of 10 to analyze. So that's pretty much it. Thanks for watching my video. See you in the next videos.